In this video for section 4.1, we're going to do the cherry supply and demand problem. This time we aren't given our supply and demand equations. We're going to have to find them ourselves. And this activity is going to show you how to do that in a couple of different ways. So we have the information here. We have a price of $1.88 per pound, and we know the supply is 16,000 pounds, the demand is 10,600 pounds. At a price of $1.46 per pound, supply is 10,000 pounds and demand is 12,700 pounds, and we're assuming linear equations. So first we're going to turn this information into coordinate pairs. And remember, when we're dealing with supply and demand equations, price is going to be the y-coordinate and number of units is going to be the x-coordinate. Now a key here is that we want supply to be in thousands of pounds. So we're not going to use the numbers here, we're going to put them into thousands of pounds. So 16,000 is 16,000 pounds. So I would put 16 in for Q. So let's see here. We want to know two coordinate pairs for the supply. So we have a price of $1.88 and supply is 16,000. So one of my points is going to be 16, comma, 1.88, $1.88. So 16,000, $1.88. My other point is when the price drops to $1.46 per pound, the supply is 10,000 pounds. So that's going to be 10 for the number of units in thousands of pounds, and the price is $1.46. So those are my 2 points. Now, to make an equation out of those 2 points, there's a couple of different ways I could do it. I'm going to show you 2 different ways in this video. One way using algebra, and then the second way using Desmos. You can choose whichever you like. You can do both and check your answers. However you want to do it is totally fine. I need a little more space to do the algebra method, so I'm making myself some more space here. So using these 2 points to find a price supply equation of the form P equals MQ plus B. So this is a y equals mx plus b equation. We need to find the m and we need to find the b. So first we need to find the slope. Using the formula, slope equals y2 minus y1 over x2 minus x1. So I'm going to label my points here. x1, y1, x2, y2, and then I'm going to plug in. So this is going to be 1.46 minus 1.88, and then divided by 10 minus 16, and that gives me a slope of 0.07 when I do that on the calculator. Supply equations always should have positive slope, and demand equations always should have a negative slope. So once I found my slope, I'm going to plug M and one of the points into y equals mx plus b and solve for b. There's another way that you could do this also using something called the point slope form. The book has more information on that, and I again need more space here. So I'm going to plug in the first point, the x1 and y1. So that's going to be 1.88 for y. Plug in 0.07 for m. And plug in 16 for x plus b. And now I'm trying to get b by itself. So my first step is to multiply 0.07 times 16. When I do that, I get 1.12. And then I can subtract 1.12 from both sides. And I get 0.76 for B. So my y equals mx plus b equation, plug in m 0.07, plug in b 0.76, and then I use m and x. But actually I want to use p and q here. I'm going to put p instead of y, and I'm going to put q instead of x. So there is my equation. Now, we're going to do the same thing for the demand. We're going to write our two coordinate pairs, and then we're going to find the equation. And this time I'm going to show you how to find the equation using Desmos. So going back to my information here, price of $1.88 per pound, demand is 10,600 pounds. So that's going to be 10.6 thousand pounds. So my point is 10.6, comma, $1.88. And then for my second point, when the price is $1.46, demand is 12,700 pounds. So 12.7, $1.46. Okay, and so now I want to use those 2 points to find an equation. So now I'm going to do it using Desmos, which is going to be a little bit faster. Again, you can do it this way if you like. If you would prefer to use algebra, that's totally fine. Whichever method you find easiest. So I'm going to insert a table, and in that table I'm going to put the 2 points that I just found. So my x coordinate here 10.6 and my y coordinate 1.88. And then my x coordinate 12.7 and my y coordinate 1.46. And so I have those 2 points on the graph. If I move a little bit, you can see where they are. They're right there. And then what I'm going to do is find the equation of my regression equation. So same as we did before, y1, use the approximately symbol, ax1 plus b. And when there's only 2 points, then the line is going to exactly go through those 2 points. 2 points make a line, and it'll tell me what the slope and y-intercept of that line are. And those slope and y-intercept are for the exact line that goes through those 2 points. So pretty neat shortcut here using Desmos. So my a is my slope, negative 0.2, and my b is 4, and that is my y-intercept. So that's my equation here that I found for number 4. Y equals negative 0.2x plus 4, or using p and q, is going to be p equals negative 0.2q plus 4. And again, with demand, we always are going to have a negative slope. So for question 5, now we're graphing the 2 equations. So I have, obviously I have my demand equation already on there. So that's the black line. I'm going to add another, in another row, I'm going to add my supply equation that I found earlier. So y equals 0.07x plus 0.76. And then it puts that line on the graph. And so for number 5, paste the link or image or both. And then finally, we're asked to find the equilibrium price and equilibrium quantity. So again, that is the point where the 2 lines cross. So looking at my graph, I can see where that is. The coordinates are 12, 1.6. So I'll write that down. And then I just need to identify which is which. So remember that quantity is going to be the x and price is going to be the y. So the equilibrium quantity is 12,000, because remember we're dealing with thousands for our x coordinates. And our equilibrium price is going to be $1.60. And the book will show you to find this by setting these two equations equal to each other, the supply and the demand equation equal to each other, and solving. You can do it that way also. Desmos is just going to be a little bit faster because it'll find the point for you right away.